Next we are going to do a question on the magnetic moment. So we have a complex and we have to calculate this magnetic moment. First of all, you're going to determine the oxidation state of cobalt here. So that's going to be Hg plus X plus 4 into SCN. Hg has a charge of 2 plus X plus 4 into minus 1 is equal to 0. So X minus 2 is equal to 0. That gives you a charge of X is equal to plus 2. So cobalt is present as cobalt 2 positive. So cobalt originally has the electronic configuration argon 3d7 4s2. So cobalt 2 positive has the formula or the electronic configuration argon 3d7. So let's draw its orbital. Okay, this is as we can see, it's either square planar or it's going to be tetrahedral. So let's see which one it is going to be. Fill in the electrons of cobalt. So that's 1, 2, 3, 4, 5, 6 and 7. Now SCN, that is the environment that the SCN provides, is not sufficient enough to cause the pairing. So pairing will not happen in 3D. 3D will remain as such. So the electrons of the SCN ligand, they are going to come into the empty orbitals, the other empty orbitals which are present. So here we can see that 3 electrons are unpaired. So if we put it in the formula, that is mu is equal to under root n into n plus 2. So that's going to be under root 3 into 3 plus 2. So the answer is under root 15. So the option B is correct. Next we come on to this question. So in this question it gives you the magnetic moment already and it asks you what is the correct distribution of the 3D electrons. So the magnetic moment of this complex is 3.83. So from this we can determine the number of unpaired electrons present. That is mu is equal to 3.83 is equal to under root of n into n plus 2. So I can square both of the sides and on squaring both of the sides I get 14.6689 is equal to n into n plus 2. So that's n square plus 2n minus 14.6689 is equal to 0. Upon solving this quadratic equation, you are going to get n is equal to 3. That is the number of unpaired electrons is 3. And you do not actually have to do all that. So the magnetic moment is 3.83. That itself means that the unpaired electrons is 3. Previously when we had calculated our magnetic moment, it came as 2.82. The unpaired electrons were 2. If the magnetic moment comes as 4 point something, then the unpaired electrons are 4. Okay. So here the unpaired electrons are 3 and chromium is an octahedral complex here, forms an octahedral complex here. Oxidation state of chromium here is 3. So chromium is 3 positive, which means it is D3. So D3 is this, this and this. These are the electrons which are going to remain unpaired, okay, and the rest of the ligands, that is the rest of the electrons of H2O, they are going to come into these orbitals, that is 3D, 4s and 4p. The cross ones are the electrons of the H2O and the arrow ones, that is the half arrows, are the electrons of chromium. So the electrons of the H2O or any ligand in an octahedral complex, they always form bonds with your dx square y square and the dz square orbitals. So these are the dx square y square and the dz square orbitals. Means that these three, that is the unpaired electrons orbitals, are dxy, dyz and dzx. So your option A is correct. That is, the configuration is 3D xy1, means in the xy orbital there is 1 electron, in the yz orbital there is 1 electron, and in the zx there is 1 electron. This is because the H2O ligands, that is the electrons of the H2O ligand, are only going to be present in your 3D x square minus y square and the dz square. That is what is going to give it an octahedral geometry. They cannot be present in an xy, yz and zx. That means that the unpaired electrons have to be present in the xy, yz and the zx orbitals.